Greetings and welcome to GILFORD'S lectures. So today, we are going to be looking at tutorial questions taken from the National Higher Polytechnic Institute of the University of Bamenda. The course from which these tutorial questions were taken is the Mathematics for Engineering 2 course, and the tutorial questions were divided into sections, and all the sections required us to evaluate integrals. So we are going to term this lecture 1, and we are going to be evaluating the integrals on the first section of our tutorial questions. So we had question 9.1, 9.2, 9.3, and 9.4. So move straight to the solutions. Before we move into solving our questions, we must first of all generally note that to integrate any function of type f of x equals x to the power a, where a is an element in the set of real numbers, we must apply the integration formula below. So this is what we call the integration formula. It says that the integral of x raised to the power a dx equals x to the power a plus 1 divided by a plus 1. As you see here, we simply added 1 to the power, that is to the original power, and we divided it by the new power obtained. And we add a constant c. And this constant c is added because this integral is an indefinite integral. In the case where we had a definite integral as such, we won't have a constant c. It's always very important for you to know that your a must always be different from -1. This is because we don't want to have situations where we are going to have 1 over 0, which is equal to infinity. Alright, let us move now to our 9.1. So for 9.1, we are going to observe that it is already given in the form x to the power a dx, where your a is equal to 4, your x equals x, and your dx is equal to dx. So you see clearly here that your x is x, that is, this x remains this x. Your a now becomes 4, as you can see here, and your dx remains dx, as you can see here. So you are going to apply the integration formula directly for a function of type x raised to the power a. In this case, your a is 4, so you are going to augment the power by 1 and you divide by the new power obtained, and you add a constant c. So you obtain this new function. Now for 9.2, it becomes very interesting as it is different from the normal form x to the a we saw above. So what you have to do here is rearrange the equation into the form we obtained earlier. So for you to do that, you simply take the half out of the integral sign, and you observe that 1 on root x is equal to 1 on x to the power half, which is equal to x to the power negative half. So that is the reason why here we obtained half the integral of x to the negative half dx. And from there you can apply your integration formula, since x to the negative half now corresponds to our x to the power a, where a is equal to negative half. So when you do that, you are going to obtain this function below, and your x to the power half plus c is equal to the square root of x plus c. So for you to arrive here, you simply have to see that this half here takes out this half below, and you are left with x to the power half plus c. That is why we obtain x to the power half plus c here, which is equal to root x plus c. Alright, so for 9.3, you see that it becomes very interesting. We can say that we have a sum and a difference of our normal form, which was x to the power a. So here, what you have to note is that the integral is distributive over addition and subtraction. In essence, for this function, we are going to see clearly that it becomes 5x cubed dx plus 6x squared dx minus 3x dx plus 1 dx. And it therefore implies that, like after applying our integration formula, we are going to see clearly that the above expression becomes 5 on 4x to the power 4 plus 6 on 3x to the power 3 minus 3 on 2x squared plus x plus c. And finally, we are going to obtain this answer. Alright, so let's move to 9.4. Alright, so for 9.4, you see clearly that it is in the form x to the power a dx, but for the fact that a constant 3 is attached to the function. So for you to treat a constant, remember it is very simple. You simply have to take the constant out of the integral sign and you proceed with your integration. And when you are done, you multiply your answer by the constant. So what you are going to do here is simply apply your integration formula when you have taken the constant out, and you are going to observe that you will have 3 into 1 on negative 0.35 plus 1, x to the power negative 0.35 plus 1, all that plus c. So this is the final answer you obtain. So as a review, if you have a constant m multiplied by x to the power a and you are integrating with respect to x, then you can always take your constant out of your integral sign and you proceed with your integration by simply applying your integration formula. I believe you learned a lot from this video. Please subscribe and turn on your notification bell. Also remember to share to all your friends through WhatsApp, Telegram, Facebook, and any other social media platform.